In the next part of our seminar, we're going to be looking at the converse of our theorem. That is, if you have a parallelogram and it turns out that the diagonals are congruent, that must be a rectangle. Sometimes this is called the construction theorem, because when you're constructing like a doorway and you want to make sure you have a right angle frame, because you don't want your frame tilting, well, rather than getting out something to measure the angles, you just make sure the opposite sides are congruent, so it's a parallelogram, and then you make sure the diagonals are congruent, so you just measure the diagonals to make sure they're the same. So in example 3, it says some artists stretch their own canvas over wooden frames. This allows them to customize the size of the canvas. In order to ensure the frame is rectangular before stretching the canvas, an artist measures the sides and the diagonals of the frame. A to B is 12 inches. Mark that down here. B to C is 35 inches. C to D is 12 inches. And D to A is 35 inches. B to D is 37. And A to C is 37. Explain how the artist can be sure the frame is rectangular. Well, we know since the opposite sides are congruent, it's a parallelogram. Since the diagonals are congruent, we're going to just use what we just did. That makes it a rectangle. I'd like you to pause this video and take a look at example 4. See if you can do that one by yourself. Now on example 4, we'll come back. Notice first off, it's a parallelogram because opposite sides are congruent. So since the opposite sides are congruent, it must be a rectangle. Nope, it must be a parallelogram for choice A. For choice B, since the opposite sides are congruent, we weren't told the opposite sides are congruent. We're told they're parallel, so that's not it. Since the diagonals of a parallelogram are congruent, STR must be a rectangle. Yes, we knew it was a parallelogram. Now, in order to show it's a rectangle, we got to show the diagonals are congruent. So your correct choice there would be C.